Today, we're gonna talk about why you shouldn't push too hard after a hot and spicy dinner at a Mexican restaurant. Because then you get, turbulence. And then you won't be laughing anymore like this, cute little brat. First of all, let's look at the Reynolds number. The Reynolds number is part of fluid mechanics. And with fluid mechanics, we can describe how a fluid, like water for example, behaves in a pipe. Or air when it meets an object, like the wing of a plane. Let's take a look at a pipe with water being pumped through it. Several forces affect the particles which make up such a flow, in this case, water molecules. On the one hand, there's the force of pressure, which pushes the particles along. On the other hand are the frictional forces that are trying to slow the particle down. It's the ratio between these forces that gives us the Reynolds number. So, the force propelling the fluid over the force slowing it down. Since you can't measure the forces on such a water molecule, there's a nice formula for the Reynolds number. Re is equal to rho times V times D whole upon eta. Rho is the density of the flowing liquid, V the speed of the flowing liquid, eta the viscosity of the liquid, and D is the characteristic length. Rho, V and eta are properties of the liquid. The characteristic length D describes the geometry of the body which the liquid is flowing through or around. It's not always the actual length, just a number that describes the body. If water is flowing through a pipe, then the characteristic length is always taken to be the diameter of the pipe. So much for the formula, but we still haven't gotten the answer everyone is waiting for. Just why can't I push after eating Mexican? Every flow has a so-called critical Reynolds number. You have to find it out by trial and error. If the Reynolds number is smaller than the critical value, then we have laminar flow. Laminar means that individual layers of the fluid don't mix and everything flows neatly, just as it should be. But if we exceed, we get turbulent flow. In a turbulent flow, things start swirling around and going all willy-nilly. This can happen when we increase the flow rate, for example. Then, the Reynolds number just gets bigger, according to the formula. And that's why you should never build up too much pressure, or you're gonna end up with a big mess. Another example would be the garden hose you have at home. If you turn it on just a little, the water flows steadily. But as soon as you open it past a certain point, it sprays in all directions. Because the flow rate of the water gets too high. It's pretty cool actually. So let's briefly summarize all this. The Reynolds number says something about the forces involved in a current. With it, we can know what type of current we are dealing with. And we calculate it using this formula. If the Reynolds number is smaller than the critical Reynolds number of the system, then we get laminar flow. If it's larger, then there's turbulence. Are you up for some more fluid mechanics? Then just click through our playlist. See you!